Okay, so is anybody here familiar with the grammar of graphics concept? A couple. How many have used ggplot2 before? A few. Okay, pretty good. So everybody's used the plot command in R, probably. Okay, so the plot command in R is really useful. This doesn't replace that. The plot command in R is generic. It's the only generic plot function, I believe, in R, where you can say plot and throw in almost anything, and if you're lucky, something interesting will come out of it. Whereas we're going to be focusing on ggplot2, which is not generic. So what I'm starting out with is, if you haven't installed these before, I'm not sure how good the wireless is at the moment, but you would say install packages plier and ggplot2, and that will get this program to run. And then I'm going to load plier. Is that font big enough in the back? Is that good? Okay. And so I'm going to take the iris data set, which is quite famous. And so this is data about iris flowers. And I'm going to run this. And what I'm doing is, let me blow this up. What I'm doing is I'm just doing a median split. So I'm going to recreate iris and call it iris2. And I'm going to use the mutate function from plier. And I'm going to mutate the iris data set, creating SW for sepal width and sepal length. And I'm going to turn those into factors. And so I'm using if-else. So I'm saying, look at this. Oh, yeah. OK. So if sepal width, the variable that exists, is less than the median, call it narrow, otherwise call it wide. And so, and I'm doing the same thing for sepal length, going from short to long. So this is a really useful kind of a split to do on your data when you're visualizing things, but it's a terrible thing to do with your data if you're doing statistical analysis. And people love to simplify their analyses by doing things like this, but you're just throwing away tremendous amounts of information. I do it a lot in visualization because we've got multiple variables here. And if we're doing 3D data and rotating the plot around, that's great if you're interacting with the data. But it's very hard to publish the result and show somebody what it is you're seeing in 3 dimensions. And if you look at some 3-dimensional plots that you see in journals where they've got like a 3D plot with lines coming up to each point trying to give you an idea of depth, it really doesn't work very well. So what I'm going to be doing here is splitting on the sepal width and sepal length so that we can essentially flatten out the 3 dimensions into multiple 2-dimensional views. Well, I guess I should run this, huh? That would help. OK, so this is what the data looks like: sepal length, sepal width, petal length, petal width, and then I've got the species of flower here, and then my SW and SL for sepal width and sepal length categorized on that median split. OK, so the ggplot2 package follows Lee Wilkinson's watershed book, The Grammar of Graphics, which I think is probably the most important book ever written on graphics. There are a lot of great books on graphics that tell you how to make a good graph and give you all kinds of advice. But The Grammar of Graphics is really at a much more fundamental level than that. And so the big idea that Wilkinson had was that every data graphic has this underlying grammar. And previously, people had done like bar plots. They'd create a bar plot program. It would do nothing but bar plots. Or they'd create a scatter plot program and do nothing but scatter plots. But Wilkinson realized that if you could work with an underlying grammar below that is incorporated into every graph, then you could create graphics not only that would do any existing graph, but you could make up any graph you could think of that no one had thought of before, and the grammar of graphics would be able to display it. So this was first implemented in SPSS in a thing called Graphics Production Language, or GPL. So if any of you have used SPSS, this might be familiar. Also, it uses the grid graphic system. So if you have learned how to use the plot function or bar plot or some of those other things that are built into R, and then you've learned how to modify those plots, those modifications won't work here. ggplot uses its own graphic system, and so you have to modify it using its own commands. So when you first learn about the grammar of graphics, oftentimes you'll be at a website, looking at how these things are created, and they generally will start out with a thing called quick plot or qplot. This is something I strongly advise avoiding, because it's like if you wanted to learn to speak German, you could learn Latin along the way, and that would help you. But how much time would you spend learning Latin? And how good would you be at Latin after you eventually got to German? You wouldn't be all that good at it. So I would strongly advise ever looking at qplot or quickplot and dive right into the grammar of graphics, which we'll do today, and you'll see that it's not that hard. So the fundamental parts of every data graphic are listed here. And the definitions are a little bit odd. When you start out with this, it's a strange view of the world. So every graph has aesthetic roles, and these are the roles that the variables have in the data. So whenever you're talking about a variable in this world, you're talking about aesthetics. The next thing is you have to have some kind of geometric objects, bars or points or lines or whatever, that are going to be on there. And the fact that the aesthetics and the geometric objects are separate is a really kind of a mind-blowing idea at first. And so these things are going to make a lot more sense when we start creating graphs. Of course, you have to be able to create statistics if you say you want to fit a linear regression line to your data or whatever. You've got scales on every plot, whether they're regular 1, 2, 3, 4, 5, or they're logarithmic. And you might have legends that indicate what colors mean or what point sizes or point styles mean. And of course, you have to have a coordinate system, which could be Cartesian, which most of us use. Could be polar if you're an engineer. Anybody use polar coordinates in their plots? Okay, couple. So ggplot, we'll handle those just fine. And then finally, if you want to take your fundamental plot and repeat it over and over for subgroups, the grammar of graphics calls those facets. Okay, so let's dive in and do some of these and see what this all means. Okay, so the first thing I'm going to do is load ggplot2. And here is my first set of commands. So what I'm saying here is I'm calling the iris2 data set. So the first argument is just the data set name. And you could say data equals, but generally people don't. And then I'm assigning an aesthetic role. And so this is just my factor sepal length, split above and below the median. So just a factor. And then I'm adding, notice the plus sign there at the end of that statement. That's very odd. I don't know that there is any other command in R that uses the plus sign to add things. And so what ggplot does with that plus sign is it's saying I'm adding a layer of display. Just like if you were using Photoshop, you could put layer upon layer upon layer. That's the way ggplot builds its graphs. So the thing I'm adding, the layer I'm adding, is a geometric object of bar, geom bar. So I went ahead and run that. And not all that exciting. We can see we have roughly the same number of flowers that have long and short sepal lengths. We did a median split, so that shouldn't surprise us too much. So that is the equivalent. We could have gotten that by just saying plot SL in R. So this is looking overly complex at the moment. So let's add something to it. So I'm adding another variable, so that's an aesthetic. So that's listed in the aesthetic function call there, the AES function call. And I'm saying sepal length is still the X thing, the X variable that I'm looking at. But now I have a role for species, And species is going to be filling up some object. And at the moment, I don't know what object yet. I haven't told it what object. But then I'm adding to that a layer that says genome bar. And so bars are going to be the objects that I'm filling up. And there's a position option for this bar, which is stack. So I'm saying I just want to stack those bars. So I tell it to run. And we can see that with long sepal lengths, the species the distribution of species is just radically different from the short sepal lengths. Oh, and by the way, you notice that we have long here and short there. I didn't catch that until just a moment ago, and I really don't like that because we're used to seeing short things near the axis. I mean, this is 0 here, so this should be shorter here. So what determines the order of those is the same thing that determines the order of factors in all plotting functions in R and all tables, and that's the order of the factor. So when a factor is created, it's created in alphabetical order, but you can specify, if you use the same labels and just change the order on the factor command, then that will set that in all of your tables and all your graphs. And independent of, it has nothing to do with ggplot2. Okay, so we're going to do now, so this is nice, but color can be expensive to publish. Has anybody published a color graph lately? What did it cost?
Printed on paper? Or
published in a journal. What did the journal charge for that? Last I heard was $600. Yeah, so if you can do this, I mean, there's no reason to do this in color. And so I mean, it's not really adding all that much information, although it looks pretty. And if these species had different colors, well, then I would think it would add a lot, and we would want to match those colors. But what we can do is we can add a function call here, which is scale fill gray. And scale fill gray added on to anything that's color in ggplot, we'll switch it to grayscale. So I'm going to run this very same plot, and there it is in gray. Okay? So now, before I've said position stack, let's do the very same plot, and now I'm saying position is dodge. And so now the objects are dodging one another. I kind of like that description. And so it's roughly the same information, just displayed side by side. Okay? So what if we want to add facets to this? We can add facet grid to any ggplot function call, and within parentheses, you specify this little formula, and on the left side are the rows, and on the right side are the columns. So I'm saying I want species broken out in columns. So let's run that. And so now it's done a lot of work for us. It's put some nice labels up here at the top, and it's put them side by side. And so this is another way to avoid color. And so we can do this kind of comparison very easily, species by species, and see that the ratio of short to long is very, very different. Okay. So pretty simple. If you were to do this with regular R plot functions, you'd have to do a bunch of work. You'd have to, first of all, say, create a 3-panel thing for me to fill in. And then I'm going to fill in this first bar plot. And that first bar plot will automatically set the axes, but if you want this comparable across all your plots, now you have to figure out which axes did it set. So you have to go in and query that object and find out, oh, that went from 0 to 50. Well, this one is not going to come out 0 to 50 in a regular plot unless you force it. So you'd have to extract from this what the range is, and then apply the range to that, and then apply the range to that. And you'd have to look at all three, figure out which had the maximum range, So you're having to look across them all, calculate maximum range, and then use that range for all three. So that would be a whole bunch of R code. I do that. How many people here are from universities? Oh, okay, bunch. So you can go back to university and go to your library. The Springer collection of books is like all free, and there's a bunch of free R books. And my R for SAS and SPSS users, you can go back and get that for free, and I've got like hundreds of, well, I don't know, probably about 100 examples of these different plots, and how to do them with the old plot function versus ggplot. Okay, so let's take a look at box plots. So we're looking at species on the x-axis and sepal length on the y-axis. And I'm going to ask for a Geo Box Plot. First, let me select just that. I'm going to leave that plus sign off and run it. And there's my box plot. And we can see there's an outlier down here. So it's measured out the 75th minus the 25th quartiles, and then it's gone, or percentiles, and then it's gone and taken 1.5 of those and run this whisker out here, and this is beyond 1.5 of those. So it's like if this were a normal distribution, this would be roughly a 95% confidence interval, but it's a distribution-free kind of a plot. So this thing is sticking out here, and I would look at that and think there's a potential data entry error. And I would go check that to see maybe this really belongs over in this other species. All right, so I'm going to add something on top of it, and that is Genome Point. And you can guess Genome Points are just going to give me points. So let's run that. And so there are the points on top. And I really like this because, you lose the information about what's an outlier, but it's still pretty obvious on this plot that there is. And you get to see all the individual values. If you had a lot of data, this wouldn't work very well because all those points would be stacked up on top of one another. So inside this white box, the fact that we see these points is a result of the fact that I called the Genome Point the second time. So if I had called Genome Point first and then the box plot second, then this would be solid white right here on each of those boxes because these layers are added in order. Yeah?
Can you also use the genome jitter to prevent overplotting?
Yes, there is a jitter, and I forget whether it's genome jitter or if it's a position. I think it's position equals jitter. Is it?
It works both ways.
Oh, both ways. Yeah, and a lot of things in ggplot, too, do work multiple ways. So yeah, if these things were all stacked up, and say you had only maybe 3 times as many data points, that'd be a great time to where they're starting to overlap and you're losing track of what's what. And so if you added jitter to it, then it would randomly throw a little noise in this direction, allowing you to see a lot more of the data. Yeah, good question. Okay, so let's add facets. And so I'm going to do the same kind of plot, only now I'm specifying facet grid, no rows, and sepal width in the column position. And out comes that. So you can see when you do a really simple plot in ggplot, you look at it and go, oh, that's kind of complex code for a simple plot. But as your plots get more and more complex, ggplot gets simpler and simpler by comparison to most other packages. So let's take a look at a scatter plot. So I'm looking here at the x is sepal width, the y is sepal length, and I'm adding nothing but Genome Point to start with. And so there are points, and you can see that there's this cluster down here, and maybe that's maybe that's all one species or something, but we don't know at this point. So there are a lot of different ways that we could get at that. Oh, and in your notes, this is titled Point Shape by Gender, but it's actually Point Shape by Species. Sorry about that. Okay, so now I'm setting another aesthetic, which is shape. I'm letting the shape be determined by species. And so it's going to change the shape, and it's going to give me a legend automatically. And then in Genome Point, I just threw in a size factor here to make them a little bit bigger so you could see the points. So let's run that. Okay, so now we can see pretty clearly these are all setosa right here. And these others are all overlapping one another. It's very hard to see what's going on with that. So shape is really not quite enough. So let's add I'm adding a line type broken down by species, and I'm also adding a geome smooth where the method is linear model. If I leave this out, if I just say geome smooth, open paren, close paren, I'm going to get just a smooth fit, a low S. A low S fit, depending on if there's enough, depending on how much data is. If there's too much data, it switches algorithms, but it gives you something very similar. All right, so let's take a look at that. So now it's doing an awful lot for us. Not only is it calculating those lines, but it's also shading in confidence intervals. And again, it's a little bit hard to see here, but the color of the points here, whether that gray is covering the black or not, or whether they, well, no, it'll only be the points in the gray. That's determined by the order. So if you had, for example, colored points, this gray would be coloring those points if the line was added afterwards. If you didn't want, and sometimes that's what you want. It's nice to see clearly which things are within the shading. But if you don't want to see that color shift, then just make the last layer your genome point. Okay, so another way we could view that is to put species on the grid. So I've decided to leave on here shape as species, because that's often what you're doing. You're kind of going along, progressing through, trying to see what makes your point the best. And so maybe you set shape as species, and now you're thinking, well, maybe let me add facets to it. So let's take a look at this. So now it's split this out, and this is a big improvement for separating these two. So these two were just like laying right on top of one another. It was very hard to see, but now it's crystal clear. But we see species labeled here, here, and here. So that's labeled by facets. So we really didn't need to change the size or the shape. And by changing the shape, it's forced a legend to appear. And I really discourage the use of legends because I don't know how many times I'm in some kind of conference, somebody throws up a graph like this, and by the time I have figured out, going back and forth several times to the legend, which is which, the slide's gone. So I haven't really had time to think about it. But if you got rid of this and just let them all be the same shape, well, it's clearly labeled right here on it what that is. And so the more directly you can label things, the better. Yeah?
What if for some bizarre reason you wanted them to have different shapes, but you didn't want a legend? So how are you going to force ggplot to not put a legend?
There is a legend equals none or something like that. There's a way to get rid of it. And I can't remember offhand if it gives you this. I think it gives you the space back, which would be a big deal. Oh, and space, by the way, is another huge factor that if I had done this in plot, and I think I do this in plot in my books, what happens is plot wants to put a gigantic white band in between these three, which really squishes it. So, to get this to look nice with the plot function just takes, an hour or something of fiddling and fiddling and fiddling. and whereas ggplot just throws it right out there, just looking gorgeous right off the bat. Okay, so now what I'm going to do is I'm going to repeat that plot, but I'm going to do it with different code. And the difference here is, here with ggplot, I'm specifying all the aesthetics and the data set. Whereas here, I'm saying ggplot nothing at all. And so really nothing needs to be supplied to this because I'm adding layers. And so I wouldn't do the graph this way unless I had a really good reason to, but I do it this way now to show you the full power of ggplot2, where I'm saying for Genome Point, go get one data set. And for Genome Smooth, maybe I'm going to go get a different data set. So in this case, it's the same data set. But the fact that you can easily plot layers upon layers from different data sets, you could have the raw data in one data set. You could have some sort of aggregation in another data set. You can have some confidence intervals from another location. And you could even have, well, what I do a lot is I like to put labels of things right on the graph. So, for example, you could take Virginica and just write Virginica right there. And how you would do that is you would create a little data set that had only 3 observations, which would be the 3 species, and their XY values would be just where do you want it. And then you could just stick it right on there. So let's see. So not only can you specify the data set separately, you can specify the aesthetics, everything, absolutely everything in each layer. You have complete independent control.
So with the are you suggesting that's a good way of actually getting text onto plots, is to create different data sets with text in them and plot them? That's easier than using Genome text or whatever?
Well, Genome text is what I would use to do it.
Okay.
Now, there is a package out there that someone wrote to automate that. And I guess sometimes it works for somebody, but I've never had it work, or maybe I'm picky. It could be that too. But when I use that automated package, and I forget the name of it, it will do that for you, but I don't like the location of things. But I do have plots to where, say I go and get, every time I do this graph, the data is a little bit different, but I go and get the maximum X value and maybe the median Y value, and then go out by 10% and put the label. And so the label, graph by graph, is shifting around kind of to match the data. So I do that, and that's what the guy, whoever wrote the package to automate that, that's what he did. The catch is that every time I get a different data set, it doesn't quite put it where I want it.
But the key point being that when you think about those things, you're not thinking about just putting a text string somewhere in space. You're thinking about plotting data. Yeah. The text is another genome, and that's part of the total flexibility of ggplot. That I've seen people that were doing bar charts with like rocket ships, where the space shuttle, the length of the shuttle was whatever amount of the payload it lifted or something like that. There were SPSS, Lee Wilkinson was working for SPSS when he invented the grammar of graphics. They used to have a contest running that said, we dare you to give us data that we can't plot with GPL, their version of it. And for a while they had their website up with just all kinds of wild and crazy plots. And I've made typos in ggplot before and gotten just a crazy, like never seen by man before plot that I wasn't trying to make. I just screwed up, and I look at it, it's like, why on earth did it do that? And then I go look at my code and go, oh wow, that's like a new kind of plot. I mean, we're just doing standard ones here, but ggplot is your imagination can go really kind of crazy. Have a lot of fun. Okay, so if you want to add embellishments. There is theme. Let me say help theme.
And you can see you can have control over everything on there. So what I'm going to do is I'm going to just do a little bit. I'm going to do a plot. I'm going to add to it the labs command for labels. And I'm specifying what my title is. I'm specifying the label for my X and Y axis. And then I'm calling the theme function. And I'm saying that the plot.title text size is going to be relatively 2.5 times as large. So these are really kind of weird the first time you see them. But it really does give you amazing control. So let's just add that to this simple plot. So it came out with the large title, the plot of the iris data up there, and then I wrote out sepal length and sepal width. So that was the only point of this plot. Otherwise, kind of a dull plot. So behind the scenes, this gray look with the white stripes running through. There's research into perceptual accuracy. I mean, that's what you really want with your graph. Whatever graph you're using, you want to make your point as quickly and as accurately as you can to whoever you're communicating to. And so, research has been done to show this is a good way to do things. For example, tick marks on the outside of the axis are better than tick marks on the inside of the axis. Because if you have a couple tick marks inside and you have a point kind of inside that, the point tends to vanish from your view. So the defaults are really good, but you might want to fiddle with those. And one of the things some journals just don't like this gray background. And so you run into that. Okay, so you can get rid of the gray background, luckily, by adding just add theme_BW to get black and white. So if you run that, there's your plot in a more standard journal style. Now it still has the major and minor. The major ones you can see, the minor ones are so dim up there you can't really see them. But you can get rid of those by creating your own theme. So I've done that for you here. So I'm creating an object called myWhite. And it starts with the theme black and white, so I don't have to specify all the things black and white already did for me. And then I'm adding to it a call to theme, and that's going to contain the plot title getting larger as I did before, and then the panel grid, both the major and minor x axes. I don't want them there at all, and same for the y axis. So once I've created my white, you don't see a result until you actually add it. So here I am adding it to the same plot, and when you see this run, the only thing that's going to happen is the gray grid, major and minor grids are going to go away. Ta-da! The vanishing grid trick. Okay, so some of the things we're not going to talk about today are interactive graphics, other than to mention them. So has anybody used JMP in here, JMP? Just one person. I really love that package. It's like you can take your data and rotate it around in 3D and study it from every angle. And you can have like 5 other plots open. And if you click on a species over here, that species lights up in all these other plots. So it's pretty cool. But of course, it's like $800. So there are ways. Let's see. There is something in R called iPlots. Has anyone used iPlots? Interactive one. All right. Interactive plots that does that kind of thing. And it's in the process of being replaced by a thing called Canvas. And Cran is where you download the stuff, and so you draw on your Canvas. That's cute. And so anyway, that's being redone with the Qt graphics kit because it's very, very fast. So their goal is to be able to handle millions of points at very high speed. And that's the problem that iPlots has. That's the problem with a lot of these
rotate your 3D stuff around products have in them is when you get too many of them, well, there's not enough jitter in the world to be able to view this mess. And so then they start going into things like density shading and so forth. So, and graphics resources. Hadley Wickham is the guy who wrote the Grammar of Graphics and something like 25 or 30 other R packages. Guy's a genius. And so his website's really good. The only downside to it is he uses QuickPlot an awful lot. So he's blending back and forth between QuickPlot and ggplot. So if your goal is to learn ggplot, it's a little frustrating. But if you see an example where he did QuickPlot and then he added a layer, all those added layers are ggplot. So it's like he's using this blend of different languages to try and simplify things. And if you were to use ggplot every day, several times a day, that would be swell. But if you use it once a week, then it's really hard to keep track of these two different languages. There is a fantastic discussion group. If you go to Google Groups and just search for ggplot2, there are tons of questions and answers already archived there. And if you don't find what you're looking for on that, if you ask the question, somebody's going to answer your question probably in like a half an hour. And if nobody answers it in a couple hours, Hadley himself probably will answer it. So this is so popular that this is roughly 10 to 15% of all discussion about R is here on this site. So it's huge.
I suspect he's a little friendlier than some of the CRAN respondents.
Yes, thank goodness for that. So if you get on our help and you don't ask your question with extreme precision, then odds are you're going to be taken to the woodshed by some professor who shall remain nameless, or multiple professors. But that's a good point, that regardless of what you're using or how you're asking your question, it's a great idea to create a little tiny simple subset. So a lot of times R has all kinds of little data generators like the rep function that will generate a little tiny data set for you. If you can generate a tiny data set, demonstrate the problem you're having and state really clearly what it is your goal is, then you'll never have a problem. You can ask a question anywhere. Even if you're commercially calling SAS Institute or whatever, you give them that information, you're going to get the best answer. On our help, if you don't give them that information, then you get ridiculed. But the Google groups are not like that. They're like super friendly. They might just say, well, the answer to that is right here. Do a search next time, please, or something. But they'll usually be very nice about it. Let's see. Hadley's book is good, although it does use QuickPlot a fair amount. I would recommend instead Winston Chang's relatively new book, the R Graphics Cookbook, where it's not just ggplot. It's ggplot plus whenever ggplot doesn't do something. For example, mosaic plots it won't do. And the reason for that is it only does rectangular and Cartesian, or rectangular Cartesian, and circular polar coordinates. And mosaic plots are hierarchical coordinates. So within this axis is like within that other axis, and ggplot doesn't do that yet. So it's on Hadley's to-do list, but who knows when we'll get to it. He's a busy guy. And my books have got lots of graphics. And rforstats.com is my website. If you go to examples, you'll see lots and lots of these examples with the code. And a lot of them are duplicated with the plot function. So if you're into S&M, then the plot function, you can spend hours and hours and hours with the plot function and do that instead of ggplot. So my blog keeps up with the popularity of things. So as of this morning, you can see that in the last year, R again grew in 1 year more than SAS Institute has grown SAS in 40 years. So that trend has continued with an R square of 0.998. Not a bad fit. Okay, so that's what I've got. Questions?
Can I make a
Yeah.
comment?
Sure.
So we had a group at UC Davis, and we went through the ggplot book together.
Uh-huh.
And this was last
Fantastic.
A lot of the things were already outdated because Hadley has, as he's redone things. But, so just be aware of that when you're working through that. You may think, it may not be, a problem with you. It may just be a problem with this package.
Yeah, that's a good point. And I'm glad you said that because with every book on R, you want to go to the book's website and download the corrections or errata or whatever they call it because R is changing so rapidly that that's a big help. And usually the authors are really good about keeping up on that. Yeah.
I completely see the value of Genome Plot, and it's wonderful and everything. And so I'm at Davis too, and I tried talking to some people, and I started using Plot and all these other functions when I started using R. So over the last several years, I've just gotten really used to doing a lot of these things, using the points and lines command, and the text command, and everything. So when I hear people just talking about it, it seems like, oh yeah, well that's just a wrapper for this other thing, or like I have this code I already use. So I'm trying to, I don't know, I want to hear your perspective as somebody who's probably got experience using ggplot and not using ggplot. Is it worth it for me to take all the stuff I already know how to do and actually
Well,
transfer?
I mean, that's a really good question. If you already know the plot function and you've already got all the plots that you routinely do, and what do? You pop it open, you change a couple of things, and it doesn't matter if it took you 2 hours to do it in the first place. You're only going to change like X and Y in the data set or whatever, and it does your plot. I wouldn't bother. I mean, I would just stick with it. Now, if it comes to be a point to where you're trying to do something really complicated and you realize you're spending hours in plot, then it might behoove you just like to throw it out there on the ggplot discussion list and say, how would you do something like this? And if you can, give them a little data set or put your data set on a website where they could pull it down or whatever, then you'll probably have an answer pretty quickly because, ggplot can do just some crazy complex plots with, just like 5 statements or something. But they are a little bit hard sometimes to figure out. And there's a thing called Plot Builder. And Plot Builder is a graphical user interface to ggplot. And it's built into Rattle, the data mining GUI. And it also comes with Deducer. So if you get either one of those packages and go and look for Plot Builder, it'll give you, just kind of give you a canvas here, and then you can just start dragging, icons and things onto it, and it will not only create the plot before your eyes, but it'll show you the code. And every now and then, I'm like beating my head against ggplot, and I think, oh heck, why don't I just go into Plot Builder and see how would Plot Builder do it? Can I figure it out? And I just drag a bunch of stuff, and I go, oh, that's the plot. Show it to me. And then there's the code, and then I see, what I did wrong. So Plot Builder is really nice. I'm trying to get Plot Builder added into other things like R Commander and so forth, but people have their views of. There is an add-on to R Commander that does ggplot, but it's really primitive compared to Plot Builder. And also, whenever I get a new object, I throw it into plot to see what comes out. Because, print, summary, and plot, those are the fundamental 3 most important functions in R, and they're all generic. And so you throw something in. You might not like what comes out of any of them, but that's the thing that the developer decided you should see. And so there are lots of plots where I don't even attempt to do them in ggplot because it's like the Tukey HSD. If you do an analysis, let's say a one-way analysis of variance, you compare these species, and if you had more species, like 10 species, it can be really hard to do all possible comparisons. Excuse me. But the Tukey HSD program or function will do those comparisons, and then you can just wrap plot around it, and it'll show you with a 0 line and confidence intervals that go back and forth. Whether if they cross 0, those two don't differ. If they don't cross 0, they do differ. And you can see lots and lots of comparisons really quickly and easily. It'd take me hours, even in ggplot, to figure out how to get those confidence intervals calculated and displayed. So, I'm definitely going to call just plot when I do something like that.
It seems like ggplot's a good starting point for
Oh yeah, I'd say if you were starting from scratch, you may as well just start right with ggplot. Yeah. Yeah.
So I was actually at that point a few months ago where I'd just moved to a new institution and I had figured out base plot well enough at this point. You know, I published in papers using base plot, and I was very much of the opinion that, oh, I don't really want to learn this. It seems like the syntax is so different from anything else in R. But I'm kind of drinking the Kool-Aid now. I think for me that I do recommend to people now that ask that maybe learning ggplot is worth the time investment. Honestly, if you're already good at using R and you use base plot, you could sit down for a few hours one afternoon and teach yourself to be really dangerous in ggplot really quickly. And I've been really amazed at the kind of figures that I can make that are much closer to publication level quality very quickly. I still use base plot for some things. There's ggmap now that makes nice maps pretty easily. And I think from another perspective, being able to do some things in ggplot or starting to port over might be useful going down the road, since that's definitely the direction it seems like the R community is heading for a lot of figures in code as you collaborate and you're sharing code with other students or faculty or collaborators that you have. A lot of people are going to be really familiar with seeing ggplot, more likely to be able to interpret that. I think than some of the really complex base plots that end up having this really crazy code associated with it to make it look nice.
Mm-hmm. Yeah.
I'll just mention that one of the projects that Hadley and the ggplot people with the channel working on is integrating it with D3, which is a JavaScript very fast graphics library. And so, I don't know when, but in a year there'll be interactive graphics, something like iPhone, but interactive graphics are the sort of thing you see on the Times website. And then you'll really want to use it because you get the interactivity for free.
Yeah, I was really shocked to learn. I went to one of the R conferences where Ross and Robert were up there, talking about R, and one of them said, plot, the plot function, that really didn't come from even S. That was like, there was a thing that lived before the S language. So, we're going back to, 1960 or something like that, and they saw this other language and they adopted plot. I mean, that's really going back there. But the fact that it's still useful and people still use it is a testament to, how flexible it is. But yeah, ggplot's really, really by comparison, quite modern. Yeah.
The thing you mentioned was like to avoid qplot, and I found I felt compelled to use it. So I have this kind of like wrapper function to do like a plot, and what I liked about it is that it's like one function where all the arguments are in there, so I could pass like multiple arguments unnamed, like ellipsis, into that one function. I'm not sure how you would do that. Maybe someone who does this can answer, or you can answer in ggplot. Since like they're all separate entities, separated by a plus sign, do you have like multiple arguments, or do you have to name them all?
Yeah, that's a good question. That could be an advantage of qplot. I'll confess, I do occasionally use qplot, and when I use it is when I'm doing nothing but qplot. So if you say, just like you say plot x comma y, and those could be continuous or those could be functions, and out is going to come something reasonable. And so I use qplot for those and only those, because as soon as you start modifying it, then you're in this weird land of sometimes it kind of modifies like the old plot function, but most likely you're going to have to put a plus sign at the end, and then you're in the new world, and my head tends to explode at that point. So, yeah, good point. Other questions? I guess the last question is, where's the food?